Okay, it's almost time, so I think it's okay if we get started. People will just keep coming in. Hey everyone, thank you for attending my talk. My name is Parshuram, and this talk is going to be about automating front-end performance metrics and making it a part of continuous integration. Now, I'm sure a lot of people here would be thinking, why such a long title? Well, there's a little bit of a backstory to it, and that's probably a good way to get started. So, my wife is a doctor. She's a dentist, and my wife attends these fancy conferences where people attend with ties and suits and all of those. And I told her that I was going to talk about browser perf at HTML5DevConf, and she was like, "Is this even real?" She doesn't get our idea of taking real-world objects and converting them to camel case. So I couldn't really, I couldn't tell her that I was going to talk about browser perf at HTML5DevConf. So hence the title. I'm going to be talking about automating front-end performance metrics and making it a part of continuous integration at the Hypertext Markup Language version 5 developer conference. You know, I actually beat her to the length of the title and the length of the conference name. So that's a win. Anyway, so welcome to my talk. As you can see, this talk is pretty much about front-end performance, how to make your websites faster and stuff. So even before we get in there, this is the obligatory slide that I have to put in to ask people why they care about performance. So before we even get started, does anyone here not care about performance? You know, the last time I spoke about something similar, there was one guy who said he doesn't because to him, functionality was much, much more important than performance. And that kind of makes sense because you want to ship before you make it performant. Anyway, so given that everyone seems to care about performance, I'm probably just going to skip this slide. And while talking about performance, the question to answer is, why does a site get slow? It's usually one of the three reasons. The first reason is that one single commit by that one single intern on that Friday night when you just went home. This guy. You all know this guy, right? It's probably due to that one single commit. Or it's probably all the functionality that we keep adding over and over and over time, which basically finally one day comes up to us and tells us that just can't take it anymore. So it's either that, or the final reason is actually my favorite. There are these tiny little snippets of code that sit around in your code base, not doing anything. They even look like angels disguised as, or bugs disguised as features. But then, when you actually look away, they get scary. This is the Doctor Who reference, but they do get scary. And how do you fix these bugs? Well, the only way to fix it is don't turn your back, don't look away, and don't blink. Good luck. So these are the three typical kind of bugs, and through this talk, I would be trying to help you understand how we can actually catch these bugs, specifically the third cute kind of bug, and how do we fix it? So, what do we usually do today when we want to fix performance regressions? The first thing we do is we are developing for the browser, so we go to the browser development tools. All modern browsers today have excellent profilers. This is the profiler from Chrome. This is the profiler from IE, and yes, IE does have a profiler. And this is a profiler from Firefox, and all of them tell you what goes on behind the scenes, how much rendering happens, and stuff like that. So there is rules, and then some great web developers amongst us have risen and made them into rules, where they say you need to do things like sharding domains, or you need to do things like enclose expensive JavaScript inside request animation frame and stuff like that. So those are typically the rules. One of the other rules is pray to the demo gods, and I think I should have done that given that you guys want to see live demo. But those are the rules. And then there's the third category, which is even more awesome. That's the tools plus rules. When I told that to my wife, she was like, tools plus rules sounds like trolls, but it's just tools plus rules. Let's keep it that way. These are typically tools that have a basic set of rules that basically encapsulate all of these rules into a kind that you can consume. Typically things like YSlow, things like Google PageSpeed, ModernIE, PageScan, and even webpagetest.org. What I'm going to be doing through this demo is introduce you to one such tool that picks up existing rules, existing known conventions, existing good practices, and tries to encapsulate it in a way that you can integrate it into your continuous performance integration. Well, before I introduce you to that tool, let's see how we measure it actually. So we have browsers. And today I'd like to introduce you to this tool called browser perf. The name is again kind of lame. I told you my bad naming conventions with camel case and stuff. So the tool is called BrowserPerf. This is a node-based tool that lets you collect all metrics from the browsers. What it basically does is it lets you run actions. Actions as in a checkout flow, or actions as in scrolling a web page, or like looking at a shopping cart or stuff like that. It runs those actions. While it's running the actions, it goes into the Chrome developer tools and picks up about tracing information, or it goes into Chrome developer tools, picks up when the rendering happens and stuff like that. And then it converts all of that data into a big chunk of metrics that you can actually use. And these are typically the kind of grades or the numbers that you would like to see across your different deployment stages. On top of that, there's the second tool called PerfJanky. Again, a bad name, but there's this tool called PerfJanky which picks up all of this data that BrowserPerf gives you, wraps it inside a CouchDB instance, and shows you pretty graphs. So what you pretty much have is one, a way to pick up all of this data, two, a way to consolidate all of this data into graphs so that you can actually use it in practice. And as I said, it stores all of this data into CouchDB, which is pretty much your data and your visualization store. And what do you get out of it? Well, you get stuff like this. This is actually the live website by my friends at Topcoat. And if you see the blue bar there, it actually has a spike. And that spike is because of that one single bad commit. The way they were able to catch this was because they were able to integrate rendering performance information into their continuous integration process. As a result, they see spikes like this, and they can catch stuff like this. Here's another example that I was playing around with. This is pretty much how Bootstrap's performance looks like for the alert component from Bootstrap 1.0.0, which was like 2 years ago, till what it was like 3 months ago, which is 3.0.0. If you look at it, Bootstrap has definitely increased in performance. There have been bumps along the way, but then they've noticed that and they've kind of decreased it. And through this talk, I'm hoping that I can convey to you how easy it is for you to generate graph like these for all of your websites. So given that you guys asked for live demo, here it is, 10 minutes of slide, and pretty much the rest is going to be demo. So what we're going to do during the demo is actually, if you look at it, this presentation is a website itself. And what I'm going to do is pretty much do performance analysis on the same website, pretty much eating my own dog food. So going back to that slide again. What I'm going to do is there are going to be 5 basic commits over which I'm going to try and profile for performance. The first one is pretty much what starts off as a hackathon project. You pick up Bootstrap, you write really bad code in 24 hours of hackathon, and you have a site running. And then after that, what people usually do is they continue working on the idea, and that's how the site started in the first place. It started at hackathon. And then after that, I went home, I cleaned up the site, and I did responsive images, I did responsive design, and I had a code that I was not ashamed of. And then people started asking me for features. They wanted to know which slide I am on, for example. So I added a scroll handler. Basically, whenever people scroll, it'll tell you which slide I am at. But then I'm not a good developer, and apparently the scroll handler was not very performant. The 4th commit basically tries to fix that. And the 5th commit is all about marketing and growth hacking, which is adding social buttons and also all those sorts of stuff. So what we're going to be doing in the demo is use our time machine, look at each commit, and look at what the performance of each commit is. So let me close Chrome and go to my time machine. Interestingly, my time machine, I can interact with my time machine on the command line, so that's good. So anyone recognize this time? First of all, is this visible, or should I make it bigger? Isn't it Control plus? Give me a minute. Yeah. So this is my time machine. It's called Git. I'm sure a lot of you also have played around with this time machine. And I'm going to check out this branch called perf, which is where all of my performance-related things are. And actually, let me not do a git log. Not for 5. Yeah. So these are the 5 commits that we're going to be looking at today. What I'm going to do is certain points in time are fixed. The other points in time are in flux. So I'm going to go to a couple of points in time that are fixed, look at what the performance looks like, and then come back. So let's start. I would say go to the first. So let's actually run the performance test for what I have right now. And this is basically a very, very simple grunt task, which I'll show you what it looks like. So all I'm going to do is I'm going to say grunt perf, and I'm going to run that. So let me go back to from the Zoom, hit enter, and hope everything works. So what this does is this starts this thing called perf janky, which automatically opens up my browser. My browser in this case is Chrome. This browser is driven using Selenium, which is here. Selenium will eventually contact and make a connection to Chromium or Chrome. It will load up the website automatically. And the test that I'm going to be doing now is trying to analyze how fast the scroll of my site is, or how fast can I scroll without jank. It's given that the internet is a little bit slower, it's taking a little longer to load all the assets, given that it also has social buttons. Actually, you know what? I'll cancel all the network requests so that it can continue. So what it does is the script automatically opens up about tracing. On the background here, you can see that the scrolling is happening. And while the scrolling is happening, all of your data is being collected on the other tab. It will eventually hit stop. Yes, it did. And here's all the data that browser perf is now picking up and crunching. If I go back here, all the crunching is done. I go back to my grunt, and yeah, it says that it has saved all of my performance metrics in CouchDB. So here's my CouchDB database interface. If you're not familiar with CouchDB, it's just a database with a front end. And when I refresh this, it creates this new database called perf slides, which is where all of my data is going to be stored. So this is the single record for the data that we ran, and these are all the metrics that it collected. You know, this is not fun. Looking at data like this is probably not fun. So let's actually do one more thing. Let's look at the data in a graph format. So I say perf slides / index.html. This index.html is again stored at the exact same point. And what we have now is data for a single point of time. So imagine that I want to find out what my mean frame time is. I click on mean frame time. And the mean frame time for my website right now is approximately 12 milliseconds. I can also have things like DOM content loaded or domain lookup time, for example. It's also a single point in time, and it took like 2 milliseconds. But you know what? This is not fun. A single point of time is good, but it doesn't look good on a graph. So let's do this. Let's go back in time. So here's what my commits look like. The top level is gone, so it's like I've gone back to yesterday, and now I'm going to run my grunt perf. I hit enter. It's going to do the exact same thing again. What it's going to do is it's going to open up Chrome for me. It's going to load all of the content, and here's the scroll handler that you see that I was talking about. This will eventually load all the resources. Once all the resources are loaded, it's going to automatically scroll, start tracing, collect all of the data that it needs. There, it finished collecting it. It's importing all of that data. All the data that you want is now available. And if I go back to my perf janky, it's crunching it, and all the data is done. Yep, there you go. So now let's refresh this graph to see what happens. See, I probably don't want domain lookup. I just want this. And let's look at the mean frame time. So obviously, the first time when we ran with the social buttons, my mean frame time was much, much higher than what I ran with when my scrolling was fixed. The question?
How is it generating? It says one is social, one is scroll fix. How is it creating those?
So those tags are here. These commits have this thing. So it can be specified anyway. But I just have those tags in the commit itself. So I say scroll fix and then sequence 4. So the next point in time you're going to see, it's going to be called scroll position, and it's going to be a sequence 3, which means it's going to come before scroll fix. So that's how the graphs are generated. And here's how the point in time looks like. So if you actually notice, my mean frame time has definitely decreased because I included third-party widgets. I included like the Twitter share button or the LinkedIn share button and stuff. That's why my mean frame time has actually decreased. If you look at the number of, if you look at the time taken for evaluating my JavaScript, this has actually decreased because if you remember, I hit cancel right away, right? In the previous demo, I hit cancel, and as a result of that, not all scripts were downloaded, and hence nothing was evaluated. And that's the reason why, in this case, social, the evaluation time of scripts is lesser. You can also look at metrics like first paint, or when did the first paint happen on my screen. Social, it was definitely much longer because I had to go hit cancel. We can also, so there are a bunch of metrics. Let me run a couple of more tests to give you a good graph, and then let's talk about how these metrics look like. So, as usual, let me go back in time once more. Whoa. And say grunt perf. And while it's running the performance, let me show you how my grunt file looks like. So here's how my grunt file looks like. Yeah. This one should be easy to zoom. So here's how my grunt file looks like. There's a single task called grunt perf which is an NPM module. All I have to do is specify what the name of the suite is, what are the URLs that I need to test, and where is my Selenium located, and where is my CouchDB located. With this 4 pieces of information, you can actually integrate this whole pretty graph thing for your own websites. So looks like it's still right. It's almost done. It's picked up all of this data. This should close, and now if I hit refresh, let's look at mean frame time again. Yeah, there you go. So given that my scrolling was bad, and then I had fixed it, you can actually see the mean frame, the difference in the mean frame. It started at 13 milliseconds. After I fixed it, it actually went to 11. And here's what happens when I add my scroll buttons, which is, again, a little higher than 11 milliseconds. What you can do is you can run these tests multiple times, and perfjanky will automatically add graphs for you. It will automatically show you the ranges so that you can ensure that the differences in ranges are not too high. Do you guys want me to run it a couple of more times, or are we good? Do you want to see one more? So what do I do? Go one more commit back and say grunt perf. And it starts it all up again. Same story. Opens up about tracing. Oops. Runs my scroll. If you notice, the environment is exactly the same. It's the same Chrome browser, a complete new profile so that no plugins are loaded. All of this information is picked up, and it now starts tracing it. And there we should have it. Now if I refresh this page, there you go. I have the 4th one. And here's the one that, so let's go back to mean frame time. So as you can see, when I actually did have the scroll handler, that was actually pretty bad. My mean frame time was bad. If I didn't have any scroll handler at all, my mean frame time was pretty good. And here's the optimized version of the scroll handler. So what this effectively tells you is, you can pick up your website. If you were to run this across multiple commits, whenever you deploy, you would actually be able to get graphs like this that will tell you what is the offending commit that's slowing your site down, or that's slowing your that's making your slide janky. Let's revert back to master. And by the way, before that, how many of you here also think that your site makes sense on mobile phones? You put your sites on the mobile phones also, right? Wouldn't it be cool if we tried testing this on the mobile? Let's do that. Let me start up my Android emulator. I think that's what it's called. And while it's starting up, how about we build a PhoneGap application or a Cordova application? How many of you know what Cordova or PhoneGap is? A good number, OK. So let's do this. Let's pick up this entire website, drop it into a Cordova application, and see how performance of a Cordova application looks like. So let me open a new tab, go to a temporary directory. Oh, I have a sample, so let me remove that. Cordova create sample. So what I'm going to be doing is I'm going to be just quickly, path already exists, rm minus rf sample, yeah. So what I'm going to be doing is I'm going to create a Cordova application. And the way to do it is create sample. And if you're interested in learning how exactly Cordova works, I think Lisa has a session later today at 4. And you should probably attend her session to see how what exactly I'm doing. But here's how I build a Cordova application: cd sample. Yep. Oops. And inside the www folder is where I'll put all my JavaScript and HTML. So let me do that. Let me copy all of my sources. I have this here, my slides, the bin folder has it all. Control C, Control V, and yes, replace. There you go. Now let me try deploying the Cordova application. I just added Android as a platform, and this will take a little bit. And I say Cordova run. What this will do is this will actually deploy my application as a PhoneGap application onto Cordova. And it does its own time for compiling, and it's done. And here is the application anytime now. There you go. So this is the exact same website. My emulator is a little slower, but this is the exact same website, but now as a Cordova application. And you know what? Let's have some fun. Let's try testing this application, and let's see how what are the performance characteristics of this application. So let me run Chrome driver, and let me run. So the other good thing about browserperf is I can run it directly from my command line. So I can just invoke the command line. I'd say verbose so that you guys can see what's happening behind the scenes. And I say pick up the config file, which is test/resources/Cordova. I'll show you what's inside this config file. But what this basically does is opens up my Cordova interface. See that it launches the app. It's actually trying to scroll. The scroll is very, very bad because it's an emulator, but it does the scrolling. It's picked up all of it, and here's all the information that you have, but now on your command line. If you look at things like, say, so to prove that this is actually a Cordova application, if you look at the navigation timing will say it's all 0 because there's no externally loaded scripts or externally loaded pages. On the other hand, you pick up and look at all the time that it takes for like picking up JavaScript or evaluating JavaScript or how many timers are there. All of it show up perfectly here. So let's actually go back to the slides. I ran grunt. I don't need Firefox anymore. So what happened to Chrome? Yep, there we are. So what we basically saw, just to summarize the whole demo part, what we basically saw was this. We went back in time across 5 commits, looked at how these 5 commits will look like, what is like the performance characteristics, stuff like that, and we were able to get some really interesting data. Now let's actually drill deeper into data to give you guys an idea of what kind of data you can get. So firstly, you can get all of the data that you get here. So if you hit F12, and if you go to profiling and you say start, and say you do something and then say stop. Did I say start? I didn't. Say start and then say stop. All of this information that you get here will be available. Similarly, when you look at the timeline, I say start, I probably will be scrolling a little bit, and I say stop again. So if you look at all of these elements here, things like paint, or when did the event happen, or what was my style calculated, or what is my composite layers, or how many events, what were the events picked up, all of this data will be available as as the graph here. So I can, you saw things like composite layers, like you saw things like event dispatch, event handlers, GC event, etc. So till now, all of the data that you had to go to Chrome to pick up can now be automatically picked up by this tool, so that you can now use it for automatic integration into your CI system and then get graphs like this. This way, you don't, every time you make a deploy, you don't have to go to Chrome, see if the deploy is fast enough, see if your site is fast enough. Add this to your website, and you will be alerted as to when the site becomes fast or when the site becomes slow. Let me quickly pause here to ensure that all of you are following along, and take questions before I move on to the next section. Questions? One question there, yeah?
So, what if you wanted to test like scrolling performance on one commit, but you wanted to do it multiple times to make sure you had an average? Because in your demo, you had a moment where there was like a hiccup and it took a little longer to get first paint, so I feel like that sort of skews the results a little. So is there a way to run multiple and get an average?
So the question is, during the demo, I showed you that I ran the test once. But the question is, can we run it multiple times? In perf-janky, you can actually specify the number of times where you want to run. So in the grunt configuration file that I showed you, here you can say how many times you want to run the test. You can say 5, you can say 10. And let's actually do that. Why not try it out, right? Oops. I need to run Selenium. Not this tab. So it's still, I ran it once. I haven't changed the parameters, but I'm just running it again. Changing the parameters is going to effectively do the same thing. What I'm going to be showing you is how does the graph look when the test is run second time, when the test is run multiple times, and how do you deal with those micro benchmark anomalies that can happen anytime. So it picks up, it's picking up all of this information from about tracing. It's picking up all of this information from the Chrome timeline. It's almost done. Almost. Yeah, there it is. How many of you actually look at about tracing when you're looking at performance calculations? A couple, OK. So this probably is a good way for you to get started, because you don't have to deal with the complexities of about tracing. You can actually have a tool that makes it much, much simpler. And now that the tests are run, the tests are complete, here's how it looks like. Actually, let me get rid of this guy. Yeah, so see this. There's this light range that you see. So effectively, what perf-janky does is if there are only 2 results, it shows you a range. If there are at least 10 results, it actually knocks out the maximum and minimum and shows you the arithmetic mean. So this is basic statistics that perf-janky picks up. So you can run the test as many times as you want, and you would pretty much get the graph. Anyone question there?
Just to add, you manually went back in history to Git. Does that tool provide a way to, for example, if I don't have perf testing or performance testing in my project, to go back to the beginning of time and see how it's been or something?
So the question is, during the demo, I had to hit git reset manually. There was no automated way to do it. The question is, does perf-janky provide a way to do that? So perf-janky is not tied to Git only. It doesn't have to be Git. It can actually be deploy time also. It can be SVN. It can be any other system. So perf-janky itself does not let you go back in time. But what you could technically do is write a simple shell script. All you need to do is, for I is equal to 1 to n, git reset head, and then grunt perf. And that'll go on and on and on and give you all of this performance information. Any other questions? One more.
Is Selenium the only test runner that's supported?
What are the other test? So the question is Selenium the only test runner that's supported? So can you give me an example of some other test runners, like Water or?
For performance stats, I don't know. Selenium's the only one I use.
So Selenium is pretty much the most popular, and that's why we support. That's why I support Selenium. But the good thing is, if you have existing Selenium test cases, perf-janky can plug in right into those. So imagine that you have a perf test that does a checkout workflow, and that's a Selenium script. All you have to do is get the session ID of the Selenium thing, and you can get performance for that checkout workflow. So it's not only about scrolling. It can be about anything. It can be about looking at products or clicking on a product detail and stuff like that. question.
So when you run the Android demo, you did a little bit of magic there because the profiling time is not accessible via Chrome driver till this version, right? So I think there's some, like, you're getting some gaps there. I think people might be confused because you cannot access the timeline as right now. What you showed that you can access all this through the tracing tool, which is you're using underneath the Chrome, the DevTools API in Chrome, right? So that does not have access through Chrome driver to the timeline, which
So the
will be the
So the question is, how do I access the timeline data from Android? Because Android doesn't provide a straightforward way. So there are two ways. The latest Chrome driver has a new API called browser.log, and you can get the logs. And one of the logs is actually performance logs. So you get 100% of your timeline data in the performance logs.
not correct. I mean, I just checking Apache into Chromium, adding that functionality, so it's not yet there. So you cannot access right now the profiling time as is right now. After the next release, you can get all the timeline.
Okay.
You cannot get the profile.
So the other place I'm picking up is I'm actually using ADB shell to go pick up. So it's not just Chrome driver. It's also ADB shell. I go use ADB shell to go pick up the tracing file. I copy the trace.json, and I don't know whether it's here, but it's probably somewhere way up. But what I pretty much do is use trace.json to use ADB, go pick up the trace for Chromium, and use that for calculating all of these metrics. So because timeline doesn't give me all the things that I need, I have to resort to using ADB. And that's how I'm doing it. OK, let's go back to the slides. One more question, yeah.
I noticed you had tags in your commit messages for Git. If I wanted to do this over like the last couple months of my commits, I don't want to have to go back and add tags to all of those.
So the only reason I added tag was because the tag can actually be a commit ID. And given that I was giving a presentation, I wanted to ensure that people know what the commit ID. I mean, just adding commit IDs in this x-axis probably is not going to be very interesting. People would not understand. But if it's your project, you actually can have these as hyperlinks, which take you to the real commit. And it can. So it's actually kind of ugly. That's one code that I'm not very proud of. But here's what I do. I read out the log message. I parse the log message manually to pick up the tag and the deploy. You don't have to do this. What you have to do is you just need to have two values. One is the sequence, which is basically the commit date. And the second one is a tag, which can be the git hash. And if you just pick up both of them, they should be good enough for you. The only reason I used this was because I wanted to show that I wanted to make my x-axis look pretty, and you guys should be able to understand it. OK, so effectively, looking back at the results again, I was able to show you that adding rendering performance and to continuous integration is not hard. Is that true? Do you guys agree? Do you think this is easy? How many think it's easy? Good, OK. Secondly, having graphs like this is much, much more important than having single absolute values in time. Primarily because when you have single absolute values in time, you have nothing to compare them against. So having graphs like this will be able to, with these graphs, you'll actually be able to say that this is the part of code that's the one that's offending and reducing my performance. Third thing, as she pointed out, beware of micro benchmarks, primarily because there are tons of things going on behind the scenes. Chrome is a very good browser. And basically, things like Selenium scripts actually do take time. So Selenium, remember that every time a Selenium script runs, it's over the JSON wire protocol. So Selenium is actually from my local machine where I start running it to the Chrome browser, and that time could vary. And there could be things like browsers actually try to optimize all of this behind the scenes. So the first time you run it and the second time you run it, they could be completely different. Finally, there are other things like what my system load is, what my caches are, how bad or good my network performance is, and stuff like that. So micro benchmarks are dangerous. So some metrics like layers or how much area was painted is good. Other metrics like mean frame time can actually be impacted by a bunch of external factors. You get lots of interesting data. I mean, this data for all practical purposes can actually be overwhelming. There's like 4 categories of data. And each has like a bunch of metrics. So there's just too much of data, and not all of this data is useful. In fact, if you're running a specific type of application, you should probably look at this data and try to understand which makes sense for you. So to give you an example in this case, the one thing that made sense for us was mean frame time, because we wanted to know how janky the website was. And this mean frame time is the exact same concept that was picked up from Chromium telemetry test cases. Similarly, the other thing that you can look at is layers. This is basically how many times a Z transform happened. And that's what, so if you notice my scroll, during scrolling, I had like multiple things, and that's why my CSS transform kicked in. The other thing that I can look at is whenever I'm doing something, what is the average area on the browser that's painted, or how much of my how much painting happens. So in Chrome, you can actually hit go to the developer tools and enable paint rectangles. This is pretty much all of that data. It'll tell you how much of the area was painted every time I do the scroll, or every time I go do a checkout workflow or stuff like that. It can also tell you things like what were the expensive event handlers. For some reason, it looks like it canceled the detection of this during the calculation. But effectively, what it will tell you is what are the cases where there are expensive paints. Basically, what are the paints that do not happen in that 16 milliseconds time frame. So in this case, the scrolling was definitely bad, and that didn't happen in 16 milliseconds. It can also give you all the performance metrics that you might get from web page test, which is all of the navigation timing, like when did the domain lookup start, when did the domain lookup end, and if you notice, things like when did the first paint happen, when did my DOM on ready fire, and stuff like this. And then, finally, the question is, I'm sure all of you guys are thinking, how do I use it for my website? Answer is not actually answer is not that hard. You install this tool called BrowserPerf from npm. I have links to all of this in the slides, so which I'll be sharing at the end. But you can pretty much install BrowserPerf from npm. You can run it from the terminal, or you can integrate it with continuous integration systems like Travis or Jenkins, anything. Alternatively, you could add it to add perfjanky to a grunt task, which will save all of this data in CouchDB. So if you're okay with having a CouchDB instance in your location, or probably use Cloudant or something like that, you could add the grunt task, which saves it all to CouchDB. Or you can use some other graphing tool like Graphite or even Excel for that matter to collect all of this data and graph it. And finally, tests are run using Selenium, but then you don't have to have Selenium. You can also use things like Sauce Labs or Browser Stack so that the Selenium itself is in the cloud. So all you'll have is this single node module. All of your Selenium setup, all of your server setup is on the cloud. And this actually picks up lots of different metrics for different browsers. It picks up, so I actually didn't show you how it runs on Firefox and IE, but it goes into Xperf for IE or WPA for IE and picks up all the profiling tools, all the profiling information. I don't have much coverage for Firefox yet, but I'm working on how to increase the coverage for Firefox. Right now, it shines on Chrome and IE. I'm working on how to get it running on Firefox. And finally, here's where the slides are located, and that's information about me. I hope this was a useful talk, and this is one tool that you guys could try and go back and try on your sites. And before I leave, one final word. A friend of mine is working on this thing called, on this service called perfmonkey.com. This perfmonkey, what perfmonkey does basically is pretty much all of that you saw, it makes it a service. So all you have to do is make a curl call, and perfmonkey will run all of these things for you. It will give you all of these results and stuff like that. So to give you an example, here's what it looks like. So I go back to my GitHub. It's probably going to take some time. It's just a very, very simple git post commit hook. So all I have to do, this was again another hackathon project. So I go here, which will eventually load. Do I have the webhook? No, I don't. I go to my settings. Where are the settings? Looks like I'm not an admin. But the idea is you can actually go to settings, add this as a GitHub post commit hook, and every time your GH pages are built, perfmonkey will build it automatically for you. So perfmonkey basically is picking up all of what you saw and making it a service. So this is pretty much all the slides I have. Questions for 10 minutes for questions. Yeah. The question is a little more details about Jenkins integration. So I don't have a Jenkins plugin yet. Effectively, you will need Node on the Jenkins system, and you can either choose to call perfmonkey from the command line, Or if Grunt is your build system, you can use perfjanky inside Grunt, or just call browserperf directly from the command line, just like you saw here. So for this example, I pretty much called browserperf from my command line. You could pretty much do that. Question?
Is the Jenkins plugin in the works?
Quite frankly, this is one guy working on a project. If you guys think Jenkins plugin is something that you would want, yes, I would start working on it. Okay. I mean, this is an open source project. I think you guys should feel free to contribute and even write it, because it looks like a lot of people want Jenkins plugin. In fact, if you have AngularJS, there's already a protractor plugin. So if you have protractor tests, this can automatically pick up AngularJS stuff and run it. Question?
What about the TeamCity plugin?
Question, TeamCity plugins. No, I have never used TeamCity, unfortunately. If you write it, please do publish it. I've actually heard 3 more people on GitHub comment on that and ask me for TeamCity plugin. Any other questions?
So you mentioned a lot of really interesting things. You said that the data can be overwhelming. What production Microsoft product do you run this against?
This is not an official Microsoft project. It's my hobby project.
Okay.
First thing, yeah, I mean, I'm not, so a little bit of background. I work for this company called Microsoft Open Technologies, which is a wholly owned, yeah, I said Microsoft and Open in the same sentence. But it's a wholly owned subsidiary of Microsoft that does a lot of open source stuff, including things like contributing to Chromium. This is not an official Microsoft product. We don't run this against any official Microsoft test cases. However, I'm just like I'm talking to you guys, I'm talking to other folks, including folks from Microsoft, to see if it makes sense to run it against production sites. So right now, I'm actually hoping that some of you may go back and look at if this can really be useful, and I'd really love to partner with you guys to find out if this can be run against your websites. And if you need help, you should probably approach me. I'm going to be hanging around. I could probably help you get this set up and run it against your websites.
For the people who are asking about Jenkins, there is so you can obtain all of these performance metrics through WebDriver. There's a couple of guys from Chromium that created all these structures for Chrome driver. So actually, you can get all this data from your Selenium test, and then actually you have to branch it or pass it to the tool if you want to. But you can actually today you don't need a plugin. You just have to integrate Jenkins with your current system, and it should work out of the box. Unless you want to integrate with your whole thing, but you can actually do it right now also through WebDriver.
So one of the other extra things it provides is the raw data itself, as I said, can be a little bit overwhelming. So effectively what you can do is, I picked up a couple of articles on the internet that spoke about performance best practices, and I was able to write them here. So these are the performance best practices things. So what I pretty much did is picked up all of the information that you get from Chromium, munged it into data that you can consume. So that's probably the other layer that you'll have to write if you're picking up directly data from Chromium. Question?
Ways to automatically identify spikes?
The question is, have I looked at ways to automatically identify spikes? Yes. What perfjanky does internally is, so this is still in the dev branch, but what perfjanky internally does is, if it actually sees a spike, and if the spike is higher than the standard deviation, it'll ignore that and run the test again. Basic statistics, but that's as low level as it is right now.
I was thinking more of like being notified when there's progression.
The question is, can we be notified? That's actually a very good point. I haven't done anything for that, but my guess is, given that all of this data is accessible, you should be able to write a notification system. Integrating a notification system should not be hard at all. One question I keep getting asked is, I have a login page. How do I run it? How do I run these tests on the page that's protected by a login page? So the answer to that usually is there's a pre-script where you can actually do the login, and that way you can either set the cookie or you can actually enter the username password, and that way all of this login wall also can be taken care of.
Can you tune in intervals? So you mentioned you did it several times, but manually. But can you set it as an option to do it like 5 times over 2 hours or something like that?
So perfjanky does not have that built in, but I have a reason to believe that why can't we do it manually? I mean, why can't we write a bash script for doing it? Or why can't it be a cron job that starts a command line every time? So I think it can. That's definitely doable. Looks like I'm also almost out of time. I actually have 10 more minutes, but I don't have any other content. I hope this was useful. Thank you guys for attending the talk. I'm going to be hanging around. If you have questions, please do come and see me.